Hi guys, as you can see, I have a face mask on. I just put a clay mask on and I was thinking to myself, well, this is just the right amount of time to do a video to go over scientific notation and a few quick tricks for you just to help convert from scientific notation into standard form and standard form into scientific notation really quick. So while my mask is setting, so I have about 10 minutes and this thing is going to get really dry. It's going to start kind of changing colors and I'm like looking in my mirror, it's already starting to tighten. So let's get right into this and then stick around till the end and I will show you what it looks like when it's all dry and I can hardly move my face. All right, let's get started. Okay guys, so let's get right into this and just please know this is not like teaching you from scratch how to do scientific notation. This is just 2 quick tips for ways to convert from scientific notation into standard form and then standard form back into scientific notation. Okay, so this is if you already know kind of the basic premise of scientific notation. All right, so speed of light. That's the first one we're going to start with, just because it's a nice, easy one. We've got 3.0 times 10 to the 8th meters per second. What we're going to do, if we want to change that into scientific notation, there's 2 ways that I recommend that you do this, okay? The first one is if we were to take the first part, our decimal here, 3.0. Okay, I'm going to write that here. 3.0, and now what I'm going to do is count the number of jumps that I'm going to move my decimal. And because I'm timesing by 10, 8 times, then I'm going to move my decimal to the right 8 times. So that means I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and that's where my decimal is going to end. I'm going to fill in the zeros. Okay, and I should have 1, 2, 3, 4, 5, 6, 7, 8 jumps. My new decimal is here, which means my new number is going to look like this. Okay, and then my decimal would be at the end. All right, new number. Really, it's the same number, it's just now it's written in standard form. All right? Now, to convert back into scientific notation, all I do is count how many jumps my decimal has to take to get to over here. All right, if I were to count it again, I have 8, okay? Then I would have 8 jumps to get back there, all right? That is trick number 1. Trick number 2 is to look at your exponent, which says 8, and what that tells me then, and this is personally is my favorite way to do this, look at your exponent, look at the number you have right after the decimal. In this case, it's a 0, and we're gonna do 8 take away 0 is 8. So that means I'm going to add 8 zeros after my number, after that decimal. 3, and then I'm going to add 1. I started to put a decimal. 1, 2, 3, 4, 5, 6, 7, 8, and then put my new decimal. Okay, so from here, where my decimal used to be, all the way down to here where my new decimal is, that's going to be 8 zeros. All right, now that doesn't always work out that way with the zeros. I'm going to show you how that'll look on some different numbers in just a second. All right, so those are 2 ways you can do it. Count your jumps, or you can count your zeros. Two different ways to do it. All right, let's look at another example. Okay, this one we have Coulombs constant. For Coulombs constant, we have 8.99 times 10 to the 9th. So for our first method, 8.99 times 10 to the 9th, again, we're focusing on our exponent. It's 9, which means we're going to have 9 jumps of our decimal point. So if I were to write that, I would have 8, and then I'm going to 9, 9. I'm going to move my decimal, 1, 2, so that's where it started, was right there, next to the 8, not after the 9. So I have to start counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9. My decimal ends right there. I'm going to fill in all these extra spaces with zeros. All right, and that gives me my new number, or rather my old number, but written in long form in standard notation. All right, so what if I wanted to use the other trick, trick number 2? Well, I can look at my exponent. My exponent is 9. I have 2 numbers here already. 9, take away 2 is 7. So what that means is I'm going to have to add 7 zeros onto the end. Add 7 zeros. So that means my new number is going to look like 8, 9, 9, and then I'm going to add my 7 zeros. 1, 2, 3, 4, 5, 6, 7. My decimal point would go at the end. And if I check that against this other one where I do the jumps, they should be the same. Let's count the zeros. 1, 2, 3, 4, 5, 6, 7. Same thing, okay? That's the way to do that. From here to here, 7 zeros. The other thing, if you're looking at this, and this is actually, this way is how my husband does it. I actually only learned that just recently. What I've always done is 8, 9, 9, 2, 3. So I would look at it as this was my, after this first number, okay, the number before the decimal, I need to do 9 numbers, whatever those numbers are, whether they're zeros or whatever, I have to have 9 numbers after that first number. So I would cover that up and go 1, 2, 3, 4, 5, 6, 7, 8, 9. It's really 2 ways of doing the same thing. Okay, but then you end up with 9 numbers after that first number where your decimal used to be. All right, that's that one there. Okay, and when you're writing that new number, you don't have to put your decimal all the way at the end there because this is your number. You can if you want to when you're rewriting it, but ultimately it just matters that you have, you know, the number right and that you know that that's where your new decimal is. Okay, I'm going to show you one more with a negative exponent. This is the gravitational constant, okay? So that's like used to determine how much gravity there is between 2 objects. So let me switch colors here. All right, gravitational constant is 6.67 times 10 to the negative 11th power. So if we're going to do this, again, we have 2 quick, easy ways that we can do this. Number 1 is, of course, we always have to start by looking at our exponent. Negative 11, that means our number is going, right now it's 6.67, our number is actually going to decrease. So all our zeros are going to be on the left side this time because we have this negative. The key though is to remember not just that, but that we need 11 decimal jumps. All right, so I'm going to start over here to give myself room to jump to the left. So if I have 6.67 6, 7, I'm going to jump to the left 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's where my decimal will end. Now I'm going to fill in all these empty spaces, like always, with my zeros. And it's a lot of zeros. That's why we use scientific notation, because it's a lot of zeros. All right, there's my new number. And that is my new decimal point. Okay. Method number 2 for negative exponents, like with the gravitational constant. If I'm going to do this, I can look at 11, and then I want to look at this time, because I'm going to the left, okay, because I'm going to the left, I want to look at how many numbers I have on the left of the decimal. So 11, take away 1, it's always going to be take away 1, because the numbers on this side always have to be between 1 and 9. I mean, it's always going to be 1. So 11, take away 1, is 10. So I'm going to have 10 zeros. All right, let's see if this works out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros. If I were to write it, I could put my decimal and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Add my 6, 6, 7, because remember my decimal point is over here now. And that is how you do that one. If you like to put 0.0 whatever, that's where you would get your 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then put the rest of my numbers. So if you add that extra 0, then that gives you 11 zeros. Okay, from there to there gives you 11. Just remember, be consistent, okay? Just you have to remember for yourself. Are you somebody that always puts 0 point whatever, or are you somebody that just puts 0.000? You just need to know yourself, and whatever you do, that's fine. You just have to stick with it and be consistent on it so that you don't confuse yourself, all right? So those are your 2 quick and easy ways to convert your scientific notation into standard notation, and then, of course, go the other way if you want to turn that back into scientific notation. So, for example, with this, we have 11 zeros. If we're counting that one, then that means I'm going to have times 10 to the negative 11th power, because it's a decimal. All right. Okay, if you have any questions about this, then leave your comments below. Hopefully this was clear enough, and I think this mask is starting to feel really tight. So let's check in and see what it is looking like. Okay, there we go. All right, you can see it kind of is cracked a little bit from when I was smiling before, and I've got my little lines from where my glasses were, so I'm gonna have to clean them off. And it's gone it's supposed to go light gray. I might have put it on too heavy, and so that part's just darker. That's how it's gonna be. And then my little nose. All right, I am going to, the things I do for you guys. Okay, so don't say I never do anything for you. All right, I am going to go wash this stuff off my face because I am done with it. And make sure that if you haven't already, make sure that you subscribe. I'm pointing to the right place this time, and click the little bell if you want to get notified, which I hope you do whenever I post a new video, so that you can learn something new or review something that maybe you forgot before. And I'm not smiling right now because I can't, it's really hard. So click subscribe, make sure to click that bell, give me a thumbs up if you like this video, and I'll see you guys later. Bye.